Good morning everyone. Today in this live lecture we shall learn relation between beta and gamma function. Actually beta and gamma functions are two functions which are Eulerian special integrals, special functions, that is beta function and gamma function. These are the two special types of functions which are expressed in terms of integration. So it is called as a special functions. Okay, now we have to discuss today relation between beta function and gamma function. Yesterday we have seen what is meant by the beta function, definition regarding the beta function, some basic properties and relations which we have studied. See this is the gamma function. We can write gamma function in the different ways. So these are the special notes regarding the gamma function which we have studied. These are the all transformation. These are the transformations of the gamma functions. This is the important formula which we have proved, gamma 1 by 2 is equals to root pi. So from this we can write this relation also. In the last lecture we have seen the definition of a beta function. How we can write the beta function? So beta of m comma n, actually it is the first Eulerian integral, special types of integral. So it is called as a beta function. Beta of m comma n which is equals to integral from 0 to 1. फरक लक्षात ठेवा, इथे इंटिग्रल 0 to 1 असतो. So integral from 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1. We can write this beta function in terms of integration with respect to y, with respect to t. In this way we can write this, that is beta m comma n is equals to integral from 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1 dx, where m comma n is greater than 0. See this. Also we can find the value of a beta function. Value of a beta function we can write. How we can write? See this. These are the values of a beta function according to the, see here, these are the values of a beta function. These first, second, third, these are the values of beta function which is obtained by taking integration by part, x raised to m minus 1 into 1 minus x raised to n minus 1. Actually there is a product in between x raised to m minus 1 and 1 minus x raised to n minus 1. So by using integration by parts we can obtain the three different modes. First, beta of m comma n is equals to n minus 1 factorial divided by m plus 1, m plus 2, dot 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 m plus n minus 1. In this case, if we consider n is positive, if we consider m is positive, then we can obtain the value of beta m comma n is equals to m minus 1 factorial divided by n plus 1, n plus 2, in this way n plus m minus 1. In this case, this is the second formula for m is positive, and this is the third formula. We can obtain the value of beta m comma n. If m and n both positive, then we can write m minus 1 factorial into n minus 1 factorial divided by m plus n minus 1. Also we have studied in the last lecture, we have proved the transformation of a beta function. This is the property, basic property of a beta function which we have proved, beta m comma n which is equals to beta n comma m. That means m and n are symmetrical or symmetric, we can interchange. So m and n are the symmetrical, that means we can interchange m and n. Second, we have studied the transformation. Beta of m comma n we can write in the another way. This is the actually basic formula for the beta, basic definition for beta, beta m comma n is equals to 0 to 1. But we can write beta function in the form of 0 to infinity, beta of m comma n which is equals to integral from 0 to infinity x raised to m minus 1 divided by 1 plus x raised to m plus n dx. Or we can write integral from 0 to infinity x raised to n minus 1 divided by 1 plus x raised to m plus n dx, means we can write, because m and n are the symmetrical, therefore we can replace in place of m and n. So we shall prove another result. Next, prove that beta of m comma n, which is equals to 1 by 2 integral from 0 to infinity x raised to 1 by 2 x raised to m minus 1 plus x raised to n minus 1 divided by 1 plus x raised to m plus n dx. We have to prove this. Actually, we know that the beta function we have, by the definition of beta function, so beta of m comma n, which is equals to integral from 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1 dx, where m comma n greater than 0. But we can transform this beta function into its another form. So by the transformation of a beta function, we have seen, see this, these are the transformation of a beta function. That means beta we can write in the form of 0 to infinity. So we can write the transformations beta of m comma n, which is equals to integral from, this is the transformation, we can write in 0 to infinity. So we can write integral from 0 to infinity x raised to m minus 1 divided by 1 plus x raised to m plus n dx. But we know that we can interchange, see this, we can interchange the beta function, we can interchange m and n. So we can write beta of m comma n is equals to integral from 0 to infinity x raised to m minus n divided by 1 plus x raised to m plus n, from 0 to infinity x raised to n minus 1 divided by 1 plus x raised to m plus n. So m and n are interchangeable, but suppose this is equation number 1, this is equation number 2, but m and n are interchangeable. So we can write, left line interchange kara, beta of n comma m, that is means beta of m comma n. You can write n comma m, and which is again we can put m comma n. So beta of n comma m, we can write, okay, you can write this is beta of n comma m, which is equals to integral from 0 to infinity x raised to n minus 1 divided by 1 plus x raised to n minus m, or that is n plus m. That means we can write beta of n comma m means beta of m comma n, which is equals to integral from 0 to infinity x raised to n minus 1 divided by 1 plus x raised to m plus n dx. Suppose this is equation 3. Now what we have to do? We have to adding 2 and 3. जे विद्यार्थी, परत एकदा सांगतो, जे विद्यार्थी सतत ॲब्सेंट आहेत, मी लिस्ट पाठवले, त्यांनी कॉलेजमध्ये येऊन भेटा, नाहीतर नंतर तुमचं हॉल तिकीट दिलं जाणार नाही. पहा, ॲडिंग 2 and 3, adding 2 and 3, so we can write left beta m plus n plus beta m plus n means 2 times of beta m plus n, which is equals to integral from 0 to infinity x raised to m minus 1 divided by 1 plus x raised to m plus n dx plus integral from 0 to infinity x raised to n minus 1. व्हेरी गुड साईनाथ सेवारे. पहा साईनाथ सेवारेचं किती कॉन्सन्ट्रेशन असतं, त्याचं पूर्ण लक्ष असतं. 1 plus x raised to m plus n dx. So integral from 0 to infinity we can write, actually both the integration having the same limits, so we can add in a single limit x raised to m minus 1 divided by 1 plus x raised to m plus n plus x raised to n minus 1 divided by 1 plus x raised to m plus n, that is a dx. Okay, so you can transfer these two on the right side. So therefore beta of m plus n, which is equals to, sorry, beta of m comma n, beta of m comma n, which is equals to, we can write 1 by 2 integral from 0 to infinity x raised to m minus 1 plus x raised to n minus 1 divided by 1 plus x raised to m plus n dx, and hence proved. This is the required proof, that is beta of m comma n is equals to 1 by 2 integral from 0 to infinity x raised to m minus n plus x raised to n minus 1 m minus 1 plus x raised to n minus 1 divided by 1 plus x raised to m plus n. In this way we can prove this. Actually this is the definition of beta function, this is the transformation of a beta function. We can interchange m and n, so we can write this and adding these two terms, then we will get required proof. Okay, बरोबर आहे का रे students? Next bit, that is a relation between gamma function and beta function. This is a very important relation. This is a very important relation. So this is a very important theorem. Relation between beta function and gamma function. Now we can write, we can prove this. See this. Prove that okay, prove that relation between gamma function, that is beta of m comma n, which is equals to gamma of m into gamma n divided by gamma of m plus n. See this. Actually we have to prove this is the relation between beta and gamma. That means beta m comma n, which is always equals to gamma m into gamma n divided by gamma of m plus n. This is our required proof. This is the relation between beta and gamma. Beta m comma n is equals to gamma of m comma gamma of n divided by gamma of m plus n. Okay, now we can prove this relation from the gamma function. See this. We have, and there is a beta of m comma n, so we have to prove this relation. We have, by the definition of a gamma function, how we can write gamma of m n is equals to, how we can write, who can tell me what is the definition of gamma n, which is equals to integral from 0 to infinity e raised to minus x into x raised to n minus 1 dx. This is the definition of the gamma function. Is it okay? Very good, Sidhshwar. Now we have to use the different properties of a gamma function. See this is the definition of a gamma function. But to prove this property, we have to know, we have to calculate. How we can calculate? We have to use the transformation of a gamma function. Where is that transformation? This transformation, which is very important to prove this property. So we have to use the transformation of a gamma function. Okay, we have proved this already. So gamma of n is equals to, हा लॅम्बडा डिव्हिजन मध्ये आहे ते लेफ्ट लाईनला घ्या. So we can write so by the transformation of a gamma function we shall write n greater than 0. Suppose this is equation number 1. Now by the transformation of a gamma function, we know that the transformation of a gamma function, that is a gamma of n which is equals to lambda raised to n integral from 0 to infinity e raised to minus lambda x into x raised to n minus 1 dx. Suppose this is a equation number 2. This relation which we have proved, this is the transformation of a gamma function. Actually basic definition of the gamma function is this. So by the transformation property we can write lambda of n is equals to gamma n is equals to lambda raised to n integral from 0 to infinity e raised to minus lambda x into x raised to n minus 1 dx. Okay, this is the transformation of a gamma function. हेच आहे पाहे. This is the transformation. Second transformation, integral from 0 to infinity e raised to lambda x into x raised to n minus 1 dx, which is equals to gamma of n divided by lambda raised to n. Or we can write gamma n is equals to lambda raised to n इकडे left ला घ्या division मध्ये. So this can be taken on the left side. So according to this definition we can write gamma n is equals to lambda raised to n integral from 0 to infinity e raised to minus lambda x into x raised to n minus 1 dx, which is equals to 0. In this case n is greater than 0. So we have to use this property, transformation of gamma function, properly. Okay, so we can write this. ठीक है, this is the part. Now we have to prove gamma m into gamma n in this way. So multiplying for this second integral, multiplying e raised to minus lambda x, multiplying e raised to lambda into lambda raised to m minus 1 on both sides. So multiplying e raised to minus lambda into lambda raised to m minus 1 on both sides of 2 means equation 2 च्या दोन्ही साइड ला मल्टिप्लाय करा. So this gamma n is it is e raised to minus lambda into lambda raised to m minus 1, which is equals to, now you can multiply. This is the lambda. Lambda means here is constant quantity, so we can take in the integration. So this lambda raised to n also we can take in the integration. So we can write integral from 0 to infinity. First of all, keep this lambda raised to n in the integration. So multiply this e raised to minus lambda into lambda raised to m minus 1 multiplying both side by e raised to lambda into lambda raised to m minus 1. On the right side there is a integration with respect to x. So for the integration with respect to x, lambda will be constant, so we can multiply this in the integration also. And also you can take lambda raised to n in the integration, so this lambda raised to n we can take in the integration also. Okay. Into, again in the integration there is e raised to minus lambda x into x raised to n minus 1 dx. So all remaining terms are as it is, there is no any problem. Okay. So we can write, तुम्ही सांगा रे काही चेंज होत असेल तर सांगा, gamma of n into e raised to minus lambda into lambda raised to m minus 1 which is equals to integral from 0 to infinity. So we can write this e raised to lambda minus lambda into e raised to minus lambda x, means we can write e raised to minus lambda x. There is a product, e raised to minus lambda and e raised to minus lambda x. So we can take this e raised to lambda minus e raised to lambda x. Again lambda raised to m minus 1, lambda raised to n. So we can write this two term as lambda raised to m plus n minus 1. So we can write this as, slowly घ्या समजून, हे खूप टिपिकल आहे, महत्वाचं आहे, व्हेरी इम्पॉर्टंट आहे. लॅम्बडा रेस्ड टू m plus n minus 1 and remaining terms are as it is x raised to m minus, sorry क्या है पा, x raised to n minus 1 dx. Okay. So now suppose this is a equation number 3. Now we can taking the integration, we can taking integration with respect to lambda, or okay आणखी एक सॉल्व करू इथं, एक मिनिट. That can be written as a lambda n into e raised to minus lambda raised to m minus 1 which is equals to integral from 0 to infinity e raised to minus lambda common kada 1 plus x bracket close lambda into lambda raised to m plus n minus 1 into x raised to n minus 1 dx. Suppose this is equation number 3. Now what we have to do, we can take out a common minus lambda here in the index of e. So e raised to minus 1 in a bracket 1 plus lambda x. Taking integration with respect to lambda. See this, taking integration with respect to lambda from lambda is 0 to infinity, lambda is equals to 0 to lambda is equals to infinity. So taking integrating with respect to lambda of this equation 3, of equation 3. So gamma n is equals to e raised to minus lambda raised to m minus 1 which is equals to integral from 0 to infinity e raised to 1 minus x 1 plus x into lambda raised to m plus n minus 1 into x raised to n minus 1 dx. Okay. So integration घ्या आता दोन्ही sides. So we can take integration from, we can take on left side integral from 0 to infinity. So this put this gamma n into e raised to minus lambda into lambda raised to m minus 1 d lambda. We have to take integration with respect to d lambda which is equals to this integral 0 to infinity. Again initial integral 0 to infinity. So e raised to minus 1 plus x raised to lambda. So we can write lambda raised to m plus n minus 1 into x raised to n minus 1 d lambda into dx. D lambda into dx. Now here on the left side, gamma n is a constant term we can take out of integral. So gamma n into integral from 0 to infinity e raised to minus lambda into lambda raised to m minus 1 d lambda, which is equals to integral from 0 to infinity. Now we shall distribute this. आता याला आपल्याला डिस्ट्रीब्यूट करा. Again we can take the infinity with respect to integration with respect to lambda e raised to minus 1 plus x raised to lambda into lambda raised to m plus n minus 1 d lambda. This is the separate integral, internal integral into पुन्हा x raised to n minus 1 dx. We have seen in the double integral, we have to take the first integration with respect to lambda. With respect to lambda, we have to take this. Okay, so what will happen here? We know that, आता पहा, we know that there is a formula e raised to 1 minus x into lambda, lambda raised to m plus n minus 1. So we can write this as, याला आपल्याला असं लिहिता येतं बाय द इंटिग्रल ट्रान्सफॉर्मेशन. हे लेफ्टला ठीक आहे गामा. आता हा फॉर्म्युला आपण लेफ्ट कडनं जाऊ. इंटिग्रल फ्रॉम 0 टू इन्फिनिटी ई रेज टू मायनस लॅम्बडा इंटू लॅम्बडा रेज टू m minus 1 d lambda, means as like this. Integral from 0 to infinity e raised to minus x into x raised to m minus 1 dx. This is the definition of gamma function with index m minus 1 means m. So we can write on the left side gamma n into gamma m, which is equals to integral from 0 to infinity. So in the bracket, now check this internal integral. आता इथं प्रॉपर्टी वापरा, e raised to lambda x. समजा हा ब्रॅकेट आपण लॅम्बडा घेऊ. कोणती प्रॉपर्टी होते पहा, तात्पुरतं लॅम्बडाला या इंटिग्रेशन साठी कन्सिडर करा. e raised to this bracket means lambda x into lambda raised to m plus n minus 1 dx. म्हणजे आपण लॅम्बडाला जर x समजलं तर कसं होतं पहा, e raised to मायनस इथं घेऊ k into x into k raised to m plus n minus 1 into dk. म्हणजे as like this property which we have to use. कशी प्रॉपर्टी वापरायची पहा, e raised to infinity integral from 0 to infinity. That means I am going to prove this here. तुम्हाला हे समजण्यासाठी इथं येऊन दिस प्रॉपर्टी शी दिस e 0 to infinity e raised to minus lambda x into x raised to n minus 1 dx. That can be written as a gamma n divided by lambda raised to n minus 1. म्हणजे ही टर्म इथं जी आहे ना ती इथं येणार आणि x चा पॉवर जो आहे n तो गामा n होणार. म्हणजे आपली टर्म कशी आहे पाहिजे ही, वी हॅव टू कन्वर्ट दिस इंटिग्रल फ्रॉम 0 टू इन्फिनिटी e raised to minus 1 plus x into lambda into x raised to m plus n minus 1 lambda raised to into d lambda. So by using this property we can write this as, यालाच कसं लिहिता येतं, so gamma of this term m plus n. So gamma of n आणि हा जो लॅम्बडा रेज टू n डिनॉमिनेटर होतो डिवाइड बाय लॅम्बडा मीन्स 1 plus x raised to n. n means here m plus n, so we can write m plus n. By using this transformation we can write this integral in this way. So we have to use this. हे तुम्हाला नीट समजलं पाहिजे पहा हे. This is very important step. So we can write down the integration in the capital bracket e raised to minus 1 plus x into lambda raised to m plus n minus 1 into d lambda. That can be written as How we can write? Gamma of m plus n divided by 1 plus x raised to m plus n into x raised to n minus 1 dx as it is. This is by using the property, or we can use this by using a second जरी म्हटलं तरी चालतं. सेकंड प्रमाण आपण अरेंजमेंट केली. याला इकडे डिव्हिजन मध्ये काय सेकंड प्रमाण होतं, किंवा बाय युजिंग द ट्रान्सफॉर्मेशन ऑफ gamma function. Transformation of gamma function, this is the cause. So we can write here in this case, now the value of internal integral, double integral होता त्यातला internal integral ची value ही आली. Now you can take gamma n plus m plus n is a constant term, so on the left side we can write gamma m into gamma n, which is equals to, this is the constant term, gamma m plus n is a constant term, so we can take out of integral gamma m plus n. So remaining terms are integral 0 to infinity. Which are the remaining term? X raised to n minus 1 divided by 1 plus x raised to m plus n dx. Okay, so we have written this gamma m plus n out of this integral. Okay, now again here you can take this gamma m plus 1. Okay, no problem, put this as it is, gamma m gamma n, which is equals to gamma of m plus n into, now see this, integral from 0 to infinity x raised to n minus 1. कोण सांगेल रे याची व्हॅल्यू? इंटिग्रल फ्रॉम, चला आन्सर सर्वांनी द्यायचं, जे आन्सर देतील ना त्यांचीच प्रेझेंटी घ्यायचं आणि त्यांचीच नाव घेऊन साईनाथ सेवारे लिस्ट पाठव. इंटिग्रल फ्रॉम 0 टू इन्फिनिटी x raised to n minus 1 upon 1 plus x raised to m plus n dx. This is the transformation of beta function. You know that. We can write this also as, see this, integral from 0 to infinity x raised to m minus 1 divided by, or this integral from beta of m comma n, integral from 0 to infinity we can write x raised to m minus 1 divided by 1 plus m plus n x dx. लाच आपण काय लिहू शकतो? beta of m comma n. So very nice, very good. So we have to convert this as a beta function, beta of m comma n, since by transformation of beta function, this is actually the transformation of beta function. So we can write this. Now you can take in the division. So gamma m into gamma n divided by gamma of m plus n, which is equals to beta of m comma n. So we can write beta m comma n, which is equals to gamma m into gamma n divided by gamma of m plus n, and this is the required proof and hence proved. Okay, hence proved. आता हा थेरम तुम्हाला परफेक्ट समझण्यासाठी काय करणार है तुम्ही? आपको ये थेरम अच्छी तरह से समझ में आए, इसलिए इसको स्टार्टिंग से लेकर एंड तक अच्छी तरह से यू मस्ट अंडरस्टैंड दिस, एंड देन यू हैव टू राइट विदाउट टेकिंग सपोर्ट ऑफ एनी डॉक्यूमेंट. यू हैव टू राइट दिस थेरम your own without seeing anywhere. So you will get the perfect of this theorem, perfection. For the perfection of this theorem, you have to write this theorem 2 or 3 times. So prove that beta of m comma n is equals to beta of m gamma of m into gamma n divided by gamma m plus n. So I shall revise this theorem. This is gamma n So transformation of gamma n is in this way, multiplying by lambda raised to n e raised to lambda minus lambda into lambda raised to m minus 1 on both sides. Then we can write this again, you have to taking the integrating with respect to x from 0 to infinity on both side. दोन्ही साइडचं इंटिग्रेशन का राईट साइडला डबल इंटिग्रेशन होतं, त्यातलं एक इंटिग्रेशन विथ रिस्पेक्ट टू लॅम्बडा आहे तेवढाच अगोदर. ऑन द राइट साइड देर आर टू इंटिग्रल्स, डबल इंटिग्रल in which one is with respect to lambda. So first of all solve that integral, which gives the result gamma of m plus n divided by 1 plus x raised to m plus n according to the transformation of gamma function. Take out gamma m plus n out of the bracket, then remaining term integral from 0 to infinity x raised to n minus 1 divided by 1 plus x raised to m plus n dx. So that is according to the transformation we can write a beta function. So this is our result. So we can write gamma m into gamma n divided by gamma m plus n is equals to beta m comma n. So beta m comma n is equals to, and this is the hence proved. This is a very important result. See this is a very important result, you must know. आता या रिझल्टचा वापर करून आपल्याला एक प्रॉब्लेम थेरम सॉल्व करायचे. सो नाउ वी शॅल मूव टुवर्ड्स दिस. प्रूव्ह दॅट, नेक्स्ट वी हॅव टू प्रूव्ह सम रिझल्ट. प्रूव्ह दॅट gamma n into gamma n minus 1 which is equals to pi divided by sin n pi, where 0 is less than n is less than 1. So we have by the beta function, by the transformation of beta function, beta of m comma n which is equals to काय रे फॉर्म्युला आता आपण प्रूव्ह केलेला, बीटा m comma n which is equals to, what is that? We have to prove. हाँ काय रिलेशन आहे, चला सांगा. So we have to prove this relation beta m comma n which is equals to, हाँ काय प्रूव्ह करायचं आहे ते सांगा. आताच प्रूव्ह केलंय ना. So we know that beta m comma n is equals to, according to the आपण definition लिहू, by the property of beta function लिहू, beta of m comma n is equals to integral from 0 to infinity x raised to, we can write this as x raised to n minus 1 divided by 1 plus x raised to m plus n dx. This is the transformation of beta function we can write, or you can also write integral from 0 to infinity x raised to m minus 1 divided by 1 plus x raised to m plus n dx. There is no any problem. And given condition is that we have given 0 is less than. Suppose this is equation number 1. Now we know that we have proved, but beta of m comma n is equals to gamma m into gamma n divided by gamma of m plus n. Suppose this is a second. Now from 1 and 2 we can write gamma m into gamma n divided by gamma of m plus n which is equals to integral from 0 to infinity x raised to n minus 1 divided by 1 plus x raised to m plus n dx. Is it okay? Is it okay? So this will be the result. Now we have to prove the sine function. We have to prove that sine function. So what we have to put m plus n is equals to 1. Now we have to substitute here in the equation 3 m plus n is equals to 1 ठेवा. That means we can write, आता परत काय लिहिता येईल पहा. So m will be 1 minus n. 1 will be, we have to put m plus n is equals to 1, then we can write m is equals to 1 minus n in this left side. So put this, m means 1 minus n, gamma n, n as it is, m plus n means 1, so we can write on the left side. So it will be gamma of 1 minus n put this gamma n as it is, divide by gamma 1, which is equals to integral from x raised to n minus 1 divided by 1 plus x bracket raised to m plus n. M plus n means 1. So we can write 1 dx. This is a 1 dx. Now you can tell me what is the value of gamma 1. Gamma 1 ची value किती आहे स्टुडंट सांगा. So we can write this gamma n, interchange करा न्यूमरेटर मध्ये, gamma n, gamma of 1 minus n divide by gamma 1. Gamma 1 means which is equals to 1, integral from 0 to infinity x raised to n minus 1 divided by 1 plus x dx. So, but we know that integral from 0 to infinity, एक rule है पा formula, integral from 0 to infinity x raised to n minus 1 divided by 1 plus x dx, it will be pi divided by sin n pi. This is the formula, integral from 0 to infinity x raised to n minus 1 divided by 1 plus x, that will be the pi divided by sin n pi. According to the इथे condition आहे पहा, for the condition 0 is less than n is less than 1. n कसा आहे, 0 is less than n is less than 1. This is the condition which we have given in the problem. Okay, so we can write therefore gamma n into gamma 1 minus n, which is equals to, we can write pi divided by sin n pi. Here in this case 0 is less than n is less than 1, and this is our required proof. So we can write hence proved. Hence proved. अशा पद्धतीनं हा result होतो. Okay, so this is the second result which we have proved. Okay, आता third result, show that gamma of 1 plus n into gamma of 1 minus n, which is equals to n pi divided by sin of n pi. So proof, LHS. What is that LHS? We can write gamma of 1 plus n into gamma of 1 minus n. That means we know that the definition of gamma 1 plus n, according to the property gamma 1 plus n, we can write, see this, gamma 1 plus n plus 1 means n into gamma n. So we have to use n into gamma n into gamma of 1 by n. वाटलं ते इथं ब्रॅकेट मध्ये लिहा, since gamma n plus 1 is equals to n gamma n. So n into gamma n into gamma n minus 1, 1 minus n. So gamma n into gamma n minus 1 minus n, we have proved that as a pi divided by sin n pi. So n as it is pi divided by sin n pi. So this is a n pi divided by sin n pi, which is equals to RHS. Therefore LHS equals to RHS, and hence proved. And hence proved. लक्षात येतं का? हे पहा, नीट व्यवस्थित पहा तुम्ही सर्व प्रॉपर्टीज. ओके, आता याच्या बेस्ड ह्याचा उपयोग काय, याच्यावर प्रॉब्लेम्स कसे सॉल्व होतात त्याचं एक उदाहरण सांगतो. प्रॉब्लेम्स, see this, we have proved these three properties. लक्षात घ्या, 1 2 3 प्रॉपर्टी आपण प्रूव्ह केलेले आहेत. See this, these are the three. Prove that this is we have proved. Okay, prove that this, this and this. Now we have to solve the problems based on this. आता याच्यावरचे प्रॉब्लेम सॉल्व करायचे. बीटा m कॉमा n which is equals to gamma m into gamma n divided by gamma of m plus n. So problems. Evaluate integral from 0 to 1 x raised to 4 into 1 minus x raised to 2 dx. Now check this. Let I is equals to integral from 0 to 1 x raised to 4 into 1 minus x square dx. But we know that there is a beta function, definition of a beta function. We have beta of m comma n, which is equals to integral from 0 to 1 x raised to m minus n into 1 minus x raised to n minus 1 dx. Now we can write this integral I in the form of a beta. So therefore I is equals to integral from 0 to 1 x raised to 4. Oh, sorry, इथं m minus 1 आहे. M minus 1 integral according to the definition of the beta function, integral from 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1 dx. So we can write, now we can write this integral I. We can write this integral I I कसं लिहिता येईल पहा, x raised to 4 ला minus 1 च्या स्वरूपात लिहायचे. We have to write this 4 in terms of m minus 1. So 4 can be written as a 5 minus 1 into 1 minus x raised to 2. 2 ला कसं लिहायचं? We have to write 2 in terms of n minus 1. So 3 minus 1 dx. Now who can tell me what is the value of m here and n here? So this is as like a beta integral from 0 to infinity x raised to m minus 1 into 1 minus x raised to n minus 1 dx. So we can write m means 5, n means 3. So we can write beta of m comma n. M comma n means 5 comma 3. But we can write beta m comma n in the form of gamma n divided by m plus n. So this is equals to gamma of 5 into gamma 3 divided by gamma of 5 plus 3. So here, since beta m comma n, which is equals to gamma m into gamma n divided by gamma m plus n. Okay. So we can use this formula. Now calculate this. I is equals to gamma 5 then gamma 3 divided by gamma of 8, and we know that gamma n means n minus 1 factorial. So this means 5 minus 1 factorial. This means 3 minus 1 factorial divided by 8 minus 1 factorial. We can write 5 minus 1 means 4 factorial, 3 minus 1 means 2 factorial, 8 minus 1 means 7 factorial. So it will be the 7 into 6 into 2 म्हणजे 3 into 5. That will be 105. Is it okay? So integral from 0 to 1, we can write x raised to 4, 1 minus x raised to 2 dx, which gives a result 100 divided by. Okay. So now we move towards the next problem, second problem. Integral from 0 to 1, evaluate integral from 0 to 2 x square into 2 minus x bracket raised to minus 1 by 2 dx. So let I is equals to integral from 0 to 2 x square into 2 minus x bracket raised to minus 1 by 2 x dx. Put x is equals to 2t. Therefore, आता इथं 1 minus x पाहिजे. We have to use the beta function. For beta function, we need 1 minus x. So, for this purpose, we have to put x is equals to 2t. So, dx is equals to 2 dt. आता limits. When x is equals to 0, then t is equals to 0. When x is equals to upper limit is 2, then put 2. 2 divided by 2 means t is equals to 1. Then t is equals to 1. So our integral becomes integral from 0 to 1, because for the replacement of a beta function, we need the integral from 0 to 1. X means 2t bracket square into 2 minus, again x means 2t bracket raised to minus 1 by 2. Again dx means 2 dt. So we can write this as I is equals to integral from 0 to 1. So 2t square, that is a 4t square, into 2 common kada 1 minus t, आणि इथं ब्रॅकेट रेज टू मायनस 1 by 2. 2 कॉमन काढल्यानंतर कसं येतं, ब्रॅकेट रेज टू मायनस 1 by 2, मायनस 1 by 2. So we can write 2 raised to minus 1 by 2, इथं minus 1 by 2. Again we can write 2 dt. So 4 into 2 dt means what? We can write 8. I is equals to 8 into 2 into 4 means 8 into 2 raised to minus 1 by 2, integral from 0 to 1. We can write this as, कसं लिहिता येईल पाहता, t square into 1 minus t raised to minus 1 by 2 into dt. Okay. आता मायनस 1 by 2 ला रिप्लेसमेंट करा. सो I is equals to 8 divided by root 2. Integral from 0 to 1. We can write this as a t raised to 2 means 3 minus 1 into 1 minus t raised to, आता पहा minus 1 by 2 कसं येतो, this 1 by 2 minus 1 we can write minus 1 by 2. That means we can replace this. Minus 1 by 2 means 1 by 2 minus 1 dt. Now we have to convert this into the beta function. I is like x raised to m minus 1, 1 minus x raised to n minus 1 into dx. So we can write I is equals to, now check this, it's a rationalization kara, it will be the 4 root 2 into beta of m means beta, m means 3 and n means 1 by 2. Is it okay? So again we can write this as 4 root 2 gamma 3 beta m comma n means gamma m into gamma n divided by gamma of m plus n means 3 plus 1 by 2. Is it okay? So we can write this as I is equals to 4 root 2 into gamma 3. Gamma 3 means we can write 2 factorial. Gamma 1 by 2. What is the value of gamma 1 by 2, student? Root pi divided by 3 plus 1 by 2 means 5 by 2, gamma 5 by 2. आणि काल तुम्ही गामा 5 by 2 ची व्हॅल्यू कॅल्क्युलेट केलेली आहे, ते इथं ठेवा. सो I is equals to 8 root 2 into root pi divided by गामा 5 by 2 ची व्हॅल्यू सांगा रे, काल तुम्ही कॅल्क्युलेट केलेलं आहे. गामा 5 by 2, 5 by 2 कसं कॅल्क्युलेट करतात पहा. गामा 5 by 2, gamma 5 by 2 means 3/2 1/2 into gamma 1/2. So it will be 3/4 रूट पाय. बरोबर आहे का? चेक करा रे. गामा 5 ची व्हॅल्यू सांगा. गामा 5/2 ची व्हॅल्यू 3/2 इंटू 1/2 इंटू रूट. सो इट विल बी 3/4. चेक करा एकदा, नसेल तर करेक्ट व्हॅल्यू लिहा. रूट 2 विल बी कॅन्सल. सो आय इज इक्वल्स टू, मग आता याची फायनल व्हॅल्यू पहा किती येते. सो पहा बरे किती येते व्हॅल्यू गामाची बघा रे. 5/2 4 5/2 1/2 4. इज इट करेक्ट? 3/2 गामा 5/2 ची काल कॅल्क्युलेट केलेली व्हॅल्यू बघा बरे किती आली. 8 चौक 32 √2 divided by 3. Okay, this is the value of, hence this is the required integral. Okay, मी आता तुम्हाला याचे होमवर्क देतो. होमवर्क. ओके, यू हॅव टू सॉल्व दिस होमवर्क. नाउ होमवर्क. फर्स्ट, इंटीग्रल फ्रॉम 0 to 1 x raised to 5 into 1 minus x raised to 3 dx. Second, integral from 0 to 1 x raised to 6 into 1 minus x raised to, that means 7 dx. थोडे मोठे येतील, चेक करा तुम्ही. 3, integral from 0 to 1 x raised to 5/2 1 minus x raised to 7/2 dx. Fourth, integral from 0 to 3, we can write this as 0 to 3 x raised to 2 into 3 minus x raised to, we can write suppose minus 1/2 dx. ओके, आता हे चेक करून तुम्ही सॉल्व करा. या ठिकाणी आपण थांबू. नमस्कार, गुड बाय. काय अडचण आली तर सॉल्व करा. यू हॅव टू सॉल्व दीज प्रॉब्लेम्स ॲज लाईक दिस प्रॉब्लेम. ओके, सर्वांनी सॉल्व करून पाठवायचं. साईनाथ शेवारे अगोदर पाठवतो. सर्वात अगोदर साईनाथ शेवारे पाठवेल. ठीक आहे, आणि बाकीचे पण ज्यांना जमतं त्यांनी पाठवू शकता. नाउ वी शॅल स्टॉप हिअर. नमस्कार, गुड बाय.